Welcome back for another Feature Friday. I'm your host, Ryan Glover, and this week we're going to be focused on adding a tags input to the Documents feature in PUP. And this is a special episode because we just released version 2.0 of PUP, which is moving us from Meteor's publications and subscriptions over to GraphQL. And what we're going to focus on in this episode is not just adding a tags input to our UI, but we're also going to look a little more closely at GraphQL and start to wrap our heads around how you actually wire up data using GraphQL, and more specifically a GraphQL schema. And that's built up of a few different parts. So we're going to wrap our heads around what are types, what are queries, what are mutations, and then look at what are resolvers, which are the functions that power queries and mutations. So we're going to wrap our head around all of that and get that wired up, as well as building a UI. The first thing we need to do to wire up tags to our documents in PUP is to wrap our heads around what the GraphQL schema is. So the GraphQL schema is where we define all the different types, queries, mutations, and subscriptions in our application. And when we want to add new data to our application, we're always going to modify this schema, and we're going to add a few different parts to it. And one of the very first parts that we're going to add to it is a type. So here you can see in PUP we've added what's called a type defs block to an object called schema, and this schema is attached to a server that's set up for you via a package we've added to PUP called PupQL. And basically what this is doing is it's starting a GraphQL server for you and attaching the schema to that server. So by attaching the schema, we mean making that server aware of GraphQL and all of the different rules in relation to data in your application. So all of that's already wired up for you in PUP. And what we need to do is modify this document types value here. So all we're really doing on this line is saying we want to concatenate the contents of this document types variable, which is imported up here on line 11. We want to concatenate that into this string literal. So if I was to type out a string real quick, just to make sure you understand this, we'll say const, this is my string. We'll say equals. Whenever you use the backticks in JavaScript, and this is ES6 and beyond, this is known as a template literal or a string literal, or the concept that's in use here, in play here, is known as string interpolation. And the reason it's called interpolation or a string literal is what it's doing is it's allowing us to embed some JavaScript into a string. So we can say this is a normal string value, but then we can say in this little syntax here, so we've got $sign and then 2 curly braces. Inside of those curly braces, we can put any JavaScript expression we want. So I could put a variable here. I could say, I don't know, call some function, we'll say get username, and I could call that. You could do all kinds of stuff, but the idea is that we're embedding some JavaScript expression into a string. And if we look down here, we have our string, and what we're doing is we're embedding or concatenating in all of the different types in our application. And types in GraphQL are a way to define the shape of the data that exists inside of our application. And if we go to this file, so we're going to look at this document types value that we're importing and adding to the string down there. We're going to jump up here to API, documents, and then we're going to open this types.js file. And what we can see is we have a slightly different syntax than we may be used to. So in the past, when we're defining the shape of data in our application, what we might want to do is call some function. So in pup 1.x, we were using a package called simple schema to help us define a schema for our data, and that required us to call to a function that would then take an object with a bunch of properties on it that we could define the shape of our data with. With GraphQL, what we're doing is we're using a brand new language, or what's known as a DSL, so domain-specific language, which is a GraphQL-only language. So if we look here, we see the keyword type followed by the name of our data and then what looks like a JavaScript object, but we'll notice that the syntax is a little bit different. So this isn't by mistake. The GraphQL DSL is designed to be relatively simple, or familiar is a better word. So it looks like a JavaScript object or JSON data or something like that, but it's not exactly the same. So we'll notice here what we're doing is we're saying we have a key name followed by a property. And when you're defining types in GraphQL, what you're doing is you're saying, this is the name of a property that might exist on this type of data. So the type of data being a document. And what we mean by might exist is we're saying each of these fields represents a possibility. So if you're used to working with schemas, or you worked with simple schema in 1.x of pup, what you were used to is explicitly stating what data was contained inside of an object in your database. With GraphQL, that changes a little bit. So what we're doing here is we're saying all of these fields might be included on a document value inside of our application. And I say inside of our application to avoid saying inside of GraphQL, because GraphQL is basically just a middleman. It's only sitting between your client and your server, and whatever communication happens in respect to data between those two, so between your client and your server, is going to pass through GraphQL. And GraphQL's job is to make sure that that data is formatted in the way that we expect. And the way that we expect is defined by things like types. And so this type here is saying we expect our data to look something like this, and for each of these fields that we've defined, we expect that that data, that specific field, so in this case I've highlighted is public, so is public, we expect that to contain a Boolean value, so a true or false value. And the idea here is that types just say, here's what's possible, and when we pass data around our application, or more specifically our GraphQL schema, we'll pass them through types. And we're going to see how to do that in a little bit. But keep in mind that what we're going to do is we're going to pass data through this type, and then GraphQL is going to use that type to filter out the data that we pass through it. So to get started, what we're going to do to make our tags feature work is we're going to add a new tags property to documents. Because the idea of what we're trying to implement is a tags input on our document editor in pup. So we want to go ahead and say, okay, this document is related to, animals or colors. So we'll say tag with blue, green, purple, red, something along those lines. And we don't want it to be terribly complex. All we want it to do is store an array of strings. And so you can see here in GraphQL, when you're defining a field that's an array value, so meaning it's going to be a nested array on our data type, we use the array brackets that we're used to in JavaScript, and then inside of that we put the type of data that's going to be in that array. And it's important to note that when you're working with GraphQL, you might hear the term scalar type. So a scalar type is just referring to something like string or Boolean, or you'll get integer or a float if it's a decimal number. That's what that phrase is referring to. And in this case, we're just saying, hey, we want to keep this simple. Let's just have an array of strings to keep track of all of our tags. Now, this covers one part of this, so we're going to go ahead and save this. And if we come back over here, make sure I didn't make any mistakes here. Let's back this all the way up. There we go. So this is back to default. And because we've already imported document types, and if we look closely, document types is just a string. So we're taking this string, and we're importing it into our schema file here, and then we're again concatenating that value into this string here. And this string is assigned to a property on our schema object called typedefs. So what this is doing is it's telling our GraphQL server all of the possible types in our application. So whenever we reference one of those types, GraphQL is going to look for it inside of the schema's typedefs field, and we want it to be able to say, oh, yep, got it, and then it's going to pass our data through that type. In addition to types, the other thing that we need to define when we're talking about data in GraphQL are queries. So queries are how we read data back from a data source in GraphQL. And I say data source specifically because there is no concept of a database when it comes to GraphQL. Or in other words, GraphQL is database or data source agnostic. It doesn't care where your data comes from. Your data could literally come from a database, it could come from an API, or it could just be some static JavaScript file somewhere located on your server. GraphQL doesn't really care. GraphQL's whole point is about moving data from your server to your client and vice versa. And the idea is that GraphQL basically acts as the police for that data. It's saying like, yes, this is allowed, or no, this isn't allowed. And the first thing that we need to do right now is take a look at this type here. So you'll notice earlier when we were defining our document type, we talked about having this domain-specific language. So we have type, and then we use the word document. And the best phrase or term that I would use to describe something like this is a custom type. So this is something that's very specific to our application and isn't going to appear in everybody's GraphQL schema. It's not something everybody's going to need to have defined. And so this is a custom type. But if we go back to our schema here, we can see something that's known as a root type. And root types are very specific. So there's 3 types of root types in a GraphQL schema. There's the root query, the root mutation, and the root subscription. And right now what we're going to do is focus on the root query. So the root query is defining all of the fields that we can actually query against inside of our GraphQL schema. In other words, if something isn't defined here, if we try and, so I'm going to open a new file here. If we try and run a GraphQL query and we say something like pizza, and for every pizza we want to know all of the toppings, we want to know the toppings, and we want to know the name of the pizza. So this is a standard GraphQL query, and we'll get more into this later once we wire up our tags on the client. But just know that this is a standard GraphQL query, and this is a field that we can query on our GraphQL schema. So imagine or assume that this outer object, so line 1 and closed on line 6, so that is our schema, and we're saying, hey schema, give us a pizza, and when you return that pizza, make sure that the toppings data and the name data are included. So if we did this, as of right now, if we look at our schema, there's not a field in our root query called pizza, which means that if we try and execute this query, GraphQL is going to throw a fit. It's going to say, sorry, that doesn't exist. I don't know what that is. I can't resolve that data. And that's another word that you're going to hear a lot when you're dealing with GraphQL, which is I can't resolve, or there's no resolver available. And when we talk about resolving data in GraphQL, a resolver is the word that you'll most commonly hear. When we talk about a resolver, what we're talking about is a function that maps back to one of our fields. And so in this case, we have documents and document. And if we look closely, what we're saying is documents here, we expect that to be a field that we can query. And when that field returns a response, meaning it finds some data to send back to the client, we expect it to return an array of our document type. So again, we defined our document here, and we can see it's got all these fields, and a little bit ago we added tags. What we expect is any data that flows through this field is going to look like a document. Or in other words, it should have, let's pull this a little closer, it should have some or all of these fields. Because again, remember that types define the possibilities, not the actual shape of every single document in our data source. So in this case, it might have some of these fields, but what we're telling GraphQL is, hey, that data that comes back through here should look like a document, or it should have the fields that we've defined on a document. And if it doesn't, and this is the neat part about GraphQL, it's going to eliminate any fields that don't actually exist. And so if we open another new file here and we say, let's say we have collections, we'll say just some documents, and this doesn't actually exist, I'm just making this up, so we're just going to have a fake array of what could be documents in our database. So we'll say one has an ID of 1, a title of hello, and we'll say it has a body of testing 1, 2, 3, and then maybe we'll have another one, we'll say this has an ID of 2, and we'll say title is testing 1, 2, 3, 4, and we'll say body is, we'll do the basic hello world. So we've got these 2 documents. Now the idea is that if we look close, we have ID, title, and body on these documents. And what I'm going to do is add a third one right after those. So this will be number 3. And this one is going to have, we'll say title 1, 2, 3, 4, 5, and then hello worlds with a Z. But I'm going to also add another field, and this is just going to be a nonsensical field. So since we were using it earlier, we'll say pizza, and we'll say Pizza is so yummy. And now that we have that on there, in a traditional application, what we'd expect is when we return the data from our database to the client, we expect pizza to be there. But this is where GraphQL and its policing functionality starts to come in. So what it's going to do is it's going to say, okay, let me get the data out of your database. So again, that's what we're expecting is this array. We're expecting it to have this array of documents. And for each one of these objects in this array, it's going to filter through this type. And GraphQL is going to say, okay, ID is here, title is here, body is here. I don't see anything about a pizza. And so what it's going to do is it's automatically going to rip that out. So if we were going to return this to the client, pizza would just go away. So even though it's a field that's actually defined in our database, GraphQL is just going to strip it out and get rid of it so we don't have to deal with it. That's one of the nice features about GraphQL. So if we jump back over to our schema here, again, that was our field document. So we're saying documents is going to return an array of data that looks like the document type. Now, the way that data actually gets returned from that field is through a resolver. So a little bit ago I was talking about, you'll hear the words resolve and resolver in relation to GraphQL. And resolvers are functions that we define inside of the resolvers object on our GraphQL schema. And you can see some repetition here. So capital Q query here is matching capital Q query here. And if we look closely, we see documents here as a field, and then down here, and this is a PUP specific convention. So this isn't something that is standard in GraphQL. This is just an organizational technique that's been added to PUP. But if you look here, we're saying ... document queries. And if we come up top, again, just like we did with document types, we have document queries imported. And so if we go over to API documents queries.js, we can see that all that's happening in this file is we're exporting an object with a couple of methods or functions defined on it. And each of these methods or functions are the resolvers. So a resolver function is nothing more than a function that returns some data back to GraphQL based on a field name. So if we look closely here, we can see documents here is mapping to documents here. And the name is significant. So if I change this to document Z, we would need to change this function's name to document Z. Or if I gave it a capital D document Z, we would have to change this to capital D document Z. So those two are one and the same. So the type is defining what's possible here, and then the resolver function is defining how to actually fulfill that possibility. Because without this function or without this resolver, GraphQL has no idea what to do. So we've told it that, hey, you're going to return an array of data that looks like a document, but in terms of actually returning that array of data, that's where your resolvers come in. So you define a function that returns some data. And you'll notice here that what I talked about earlier with GraphQL being data agnostic or data source agnostic, in this code we are utilizing the existing Meteor MongoDB implementation, but all we're really doing is just returning an array of data as far as GraphQL is concerned. So if I demystify this a little bit, so we're using shorthand JavaScript here to write this, but if I demystify this, this is all we're doing in this file. So I'm just saying return, and then we'll talk about this logic in just a second, but all I'm saying is return documents.find.fetch. And the .fetch is a Meteor MongoDB specific thing that's saying give us back whatever documents you find as a JavaScript array. And so that's it. So I could just as easily get rid of this and just return some static data, and GraphQL doesn't care. So again, as long as the data in the value that we return matches the type that we've defined, GraphQL could care less. It's just going to say, great, everything looks good here. And so if I say ID 123, and then we'll say title, and we'll say testing, let's fix that one, testing GraphQL, and say this was all the data that we sent back. So our array had an object in it, but it only had ID and title. As far as GraphQL is concerned, this is perfectly fine, because what we're doing is we're matching GraphQL's expectations for the shape of the data that we specify as being returned from our field. So here we're saying document is going to return, actually let me back that up, there we go. Documents is going to return an array of the document type, or something that looks like it. So again, it doesn't have to be exact, it just has to look like it. So here I'm only returning ID and title, and if we go back over to our type, hey, guess what? ID and title are fields that are defined, or those are possibilities for fields defined on the data that we return. So that's it. That's all we have to do. And so this is so far the magic of GraphQL. So let me back this up, and we're going to talk about one little detail here that's specific to pup. So this shorthand here, you'll notice I got rid of the braces. This is just because we're using an arrow function without any actual logic going on in the body, which means we're doing what's known as an implicit return. So all this function is doing is returning some data, and that's it. And so we can omit the braces and all the extra hoo-ha, because JavaScript will just say, oh, okay, you just want me to return whatever this line is immediately following the fat arrow here. And so if we look, what we're doing is we're saying context.user and context.userid question mark. So this whole line here is known as a ternary expression or ternary operator. And so the idea is that we're saying if this is true, question mark, so if that's true, do this, otherwise or else do this. So if we read this out as a sentence, what we're saying is if there's a user and that user has an ID, return whatever documents you find where that user is the owner as an array, otherwise just return an empty array. And so here, context.user is a value that we're given by pupql. So pupql, again, is starting up our GraphQL server for us. And what it's doing when it starts that server is it's also saying, hey, here's the logged in Meteor user in the application. So in the past, when we were dealing with methods in Meteor, we would get the value this.userid that we could use to say, here's the current user's ID that's logged in. This is the exact same thing that's happening back over here. The only difference is that instead of saying this.userid, what we're doing is we're assigning the entire logged in user object to the context argument on our resolver. And that's important because if we look closely here, these two example resolvers that we've built into pup, there's a lot of similarity between them. Specifically, the function that we return has 3 arguments on it. So we can see parent, args, and context. And we're going to ignore parent for now, but what we need to know is that args is an object containing all of the arguments that we've passed from the client. So because we're dealing with a query here, if we want to say only give us back documents with this specific ID. So if we look down here, we can see that document is saying, hey, only give us back where the document ID is args._id. Args are just arguments, it's just short for arguments, that are passed from the client that allow us to say, hey, give us this specific thing back. And as we'll see in a little bit, they're also where we store data that we want to add to our data source or add to our database. So those are always going to be present. And then context is just a generic object with metadata information. So it's basically the kitchen sink, so to speak, as far as our GraphQL server is concerned. So it just contains the current context that we're working within. And again, pupql, the tool that we use to start the GraphQL server for us inside of pup now, what that's doing is it's attaching the current user for us to that context object so that if there is somebody logged in, we're always going to have access to their information inside of our resolver functions. The next thing we need to talk about are mutations. So what we're seeing here is known as a query. So if we go back to our GraphQL schema real quick, remember we talked about the root query type where we define fields that we can actually query against or request data back from our client to our server. Mutations are, like the name kind of implies, when we're trying to change data. So this would be the C, U, and D in CRUD. So instead of create, read, update, delete, this is just the create, update, and delete. So this is us physically changing some data in our application. And the exact same principle that we saw at play when we talked about our root query. So we talked about a field defined on our root query, as well as the resolver paired with that root query, that field defined on the root query. Mutations are the exact same concept at play. So a mutation is a field, And the major difference is that the field more commonly, so it's not that queries can't do this, but more commonly mutations take in some value or take in some arguments and pass those to a resolver function to do something with, and then return a value in response. So just like we saw up here when we were querying for documents, we return an array of documents or array of the document type or data that looks like the document type when we're querying or just requesting data back. When we're doing a mutation, what we're going to do is actually say, okay, we want to, we'll say here, update a document. And when we update that document, the syntax changes a little bit. So we're saying add parentheses after the name of the field, and each of the values that we put here, so we're saying ID, title, body, and is public, each of these are the arguments or args that are passed through to our resolver function's args object. So that second argument that we saw passed to our resolver function, these values here are describing what's allowed to be passed through that args object or to that args object. So if we look here, update document is talking about taking in an ID as a string, a title as a string, a body as a string, and is public as a boolean. And we'll notice specifically that ID here has a string exclamation point. So what that's saying is that whenever we call our update document mutation, ID is required, and it's required as a string. So no matter what, so if we get rid of this exclamation point, we're saying that if ID is passed from the client to the server, ID must be a string. But if we add the exclamation point, we're saying it doesn't matter what you do, ID has to be passed as an argument to this mutation when you call it. So when we call update document, we have to pass an ID, which is describing the document that we're actually trying to update. And so this is saying, here's our field and here are the arguments that we expect. And all of these others are optional because they're missing that exclamation point. So only if it has the exclamation point is GraphQL going to yell at us if we don't include something. So in this case, we're just saying, hey, if there's a title, great, just make sure it's a string. Same exact idea with body. And then for is public, make sure that it's a boolean or a true false value if it's passed. And then here we can see something similar to what we saw up above with our query field. So here with the mutation field, what we're saying is we expect our mutation, once it's done changing our data or updating our document, to return data that looks like a document. And in this case, we're saying a single document. So keep in mind that up here we had an array of documents being returned. Here we're saying just give us one document. And so just to make sure this is super clear, because document is kind of a generic word in programming, we're not saying just any document. We're saying literally the concept of documents in PUP is like documents. So you're writing like a Word document or a Google Doc or something like that. So it's a document with just some text in it. That's what we mean by document. So here document is just describing the type of data that we expect to be returned from our mutation once it's called. And so what we need to do is take a look at update document, and we're going to look at the mutation resolver function. So again, just like we saw with queries having resolver functions, our mutation, or our root mutation field, so again, capital M mutation here matches capital M mutation here. So if something is defined here as a field, it needs to have a resolver function with the exact same name defined on this object. And here we're using the ES6 spread syntax to just say, hey, go ahead and unpack the contents of whatever this variable is onto this object. And so right now, if we go and look at document mutations, so we're going to go up to API, documents, and then mutations.js, we can see exactly what we saw before with our query mutations, or excuse me, not our query mutations, our query resolvers. So these are just resolver functions that say, hey, I'm supposed to change data in some way. And then when I'm done, I need to return some data. So in this case, if we go down to our example of update document, remember, GraphQL doesn't really care what happens or how we're interacting with our data source. It doesn't even care what our data source is. So we could do whatever we want and consider that being the action of updating a document or the mutation of updating a document. And so in this case, what we're doing is we're saying, hey, we want to update a specific document inside of our documents collection, our documents MongoDB collection inside of our application. And so here, again, we have this args argument that's passed to our resolver function, and what we're saying is, hey, pull the underscore ID property off of that. And remember, back here in API.js, if we look at the field where we define update document as a mutation, that ID is required because of that exclamation point. So back over here, we absolutely cannot do anything without that ID. So us passing it here is meaning that ID is required here in our mutation. So if we look, we're saying, okay, we're going to update this specific document with this ID, and then we're going to do a MongoDB set. And what we're saying is we're going to spread out, again, that spread operator, ES6 spread operator is saying unpack the contents of this object, so the args object, onto this object. So literally the value we're telling MongoDB to set in the database. We're saying, hey, set these values on this object or on this document in the database. And this document meaning the one matching this ID. So we're saying, hey, take all of the args that we pass and set them on, and then also take the body field and make sure that you sanitize the contents of it. And we're going to ignore that for now. That's not terribly important to what we're discussing. But just know that all we're saying here is if body is passed from the client inside of this args object, go ahead and take it and sanitize the contents of it. And again, we're going to ignore that. Just know that it's basically scrubbing out the HTML tags that are used in the body of the document, so that way we don't have any security problems with our application. So we're changing that field, and then we're saying add a timestamp for the updated at. So we're saying this is when this document was updated. And we can see here, that's all we're really doing. We just make our change to our data. Again, it's just a function being called by GraphQL with some consistent arguments, so root, args, and context. Otherwise, we don't really care. We're just saying, hey, go ahead and update this document. Once we're done, remember back here in API.js, we say that if we call our mutation update document with a document being returned, we expect a document to be returned. So here we're saying, okay, pull this specific document back out of the database after we've performed our update. So we expect this to reflect the current state of the document after our changes have been made. And so we return that doc back to the client. And now you may be wondering, wait a minute, aren't we supposed to be talking about tags and all that stuff? And the answer is yes. So what we need to do here is make sure that our resolver functions are aware of tags. And technically speaking, right now, the way this is written, this mutation, or this resolver function, let me make sure that's super clear, this mutation resolver function. So again, you have resolver functions for all of your queries, your mutations, and your subscriptions in GraphQL. So this mutation resolver function is saying, hey, I'm going to update this document again being whichever ID we pass on the args object. I'm going to update this document with all of the args passed to me. And so what we need to do is go back to our API.js file and make sure that we include tags, and we want it to be an array of strings. So again, remember, we need to tell GraphQL explicitly, hey, this is what you should expect as an argument to this mutation when it's called. So we're saying, if we're going to update this document, go ahead and add some tags to it, or support tags being added to it. I can't say that it's explicit. We could technically add an exclamation point here, but we're not going to do that. We're just going to say, hey, it should be an array of a string scalar type. So just an array of JavaScript strings, that's it. So this is great, but we have one other place that we need to add this, and that's right above on the add document mutation. So here we have to keep in mind that when we create a document for the first time, we might add some tags to it. So we need to do the exact same thing. We're going to say, hey, tags might be an argument that's passed to add document. And again, this is another mutation. So if we go back into our Mutations.js file under API documents, if we go back up to add document, we can look here and we can see, okay, so we're saying add the title, add the body. So we've got a little bit of a discrepancy here. So unlike down here where we were just saying, hey, go ahead and unpack or spread the contents of the args object onto this object we're passing to our set, up here we're a little more picky about what we're passing. And so we need to make sure that we take that into consideration. So what I'm going to do is just beneath the body field here, I'm going to add tags in. And as you might assume, we're going to say args.tags because we expect args.tags to exist based on what we defined here. So we've got tags being added to the possible arguments for update as well as for add. So back in our add, we expect args.tags to be defined. And here we're saying go ahead and add them for the first time because we're creating a document for the first time. And then down here for the update, again, this is just saying give us all of the args that are passed and set them on the document. So if we happen to pass tags, those will be set on our document. And then that document is again going to be returned whenever we do an update. And so we expect it to have those new tags on the document when it's returned. If we look closely, same exact thing is happening with our add document resolver function. We're saying go ahead and create the document and then return that document to us so that we can work with it back on the client if we need to. Alright, so now that we have our mutation resolvers updated, we've got our schema updated to know about the changes to the arguments that we're passing from the client. We've got our query updated to make sure that that's all working. We've also added tags to our document type back over here. So this is our document type and we've added tags. We've got everything we need now complete on the server or in our GraphQL schema in order to support the data that we want to add on the client. So what we're going to do is jump over to the browser, and here I've got a copy of PUP 2.0 running. So what we're going to do, and if we look here, so I'm on the documents page inside of document 1, and what we want to do is down here just above this footer where it says markdown supported, we're going to add our tags input. And to add our tags input, what I'd like to do is use a package that I really like called React Select. And as you can see, it's super popular. It's 14,500 stars on GitHub. So this is not just a passing fancy type of package. This is a pretty serious library that a lot of folks depend on. And what I want to do is look at the creatable input inside of React Select. So React Select gives you a lot of different select style inputs that you can work with. But I want to use creatable specifically because, and if we go to the creatable page on the React Select website, I want to use this one because it's got a traditional tags input. So here this one is saying creatable multi-select, and the word creatable is important. So this means that we can add our own tags. So I'm going to say add a tag, beagles are cool, look at that, and there we go. So like we might expect when we think about a traditional tags UI, this component is going to give us access to that. So what we're going to do is go ahead and install this now, and then we're going to start working with it. To install the package, what we're going to do is inside of our terminal, and this doesn't matter if the project is running for you. So here I've got our app running in another terminal window on my machine. So it doesn't matter if the app is running or not, but inside of the project directory from your terminal, what you're going to do is run meteor npm I or install. So that's just short for the keyword, the entire keyword install. So we're going to say meteor npm I -- save to make sure that this gets added to our package.json file. So that way, once we move this off of our computer and into something like Git or put it onto GitHub, that package is going to be denoted as something that our application depends on. And if we move it to another machine or we want to share it with another developer, they'll know that they have to download that package to their machine through that package.json file. So that's what -- save is doing. And what we're going to do is say save react - select. So we'll go ahead and install that. And then what we're going to do is jump back over to our browser here. And again, we want to look at the code for this. And so what we need to do is implement the basic concept that's in play here. And what we're going to do again is add it to our documents editor here. So what I'm going to do, and let's double check. Looks like we're all updated and it's installed. So let's close out all these GraphQL files that we've got here. And we're going to jump down to the client. That's kind of a weird expression, huh? So we're going to jump down to the client, even though all we're really doing is just moving between files. But for some reason, mentally, that helps. So by jumping down to the client, what we mean is we're going to go to the UI folder at the root of our project. We're going to say UI, and in this case, we're looking for a component. And we're looking for the document editor. So we're going to open this up. We can see that the document editor is just a React component. with a bunch of stuff going on in relation to working with editing a document in PUP. So literally what you see here in terms of code is what's being rendered on screen here. So this is allowing us to say, this is a title change and updating a document. It's doing all of that work for us. And what we need to do is modify this component so that it can include that tags input that we're after. So what we're going to do is jump up to the top of our file here, and I'm going to add this here. I'm going to say creatable select, so we know exactly what we're dealing with. And this is coming from react-select. I believe it's /lib/C creatable. Ha! Look at that. Look at that memory. And what we're going to do is copy this and jump down here. And let's say, so this is our footer right here. So we're going to put this right here. And what I'm going to do is define a styled component. So if you've never seen styled components before, what this allows us to do is create React components that have CSS styles applied to them. And it does it in a really novel way with a nice syntax. And this is something that's built into PUP. This is what we use for all of our CSS in PUP. We've been using it since, I want to say it was PUP 1.6, but this is standard in PUP 2.0 as well. So what I'm going to do is just type out a component. This doesn't actually exist, but we're going to make it. So I'm going to say this is the document tags styled component that we need to create. And inside of that, I'm going to add creatable select. And following the documentation, we're going to say it is multi, so that way we can add multiple tags at once. And then I'm going to say it's going to need an onChange handler. And I'm just creating that as a placeholder right now, so we'll type that in just a second. So we're going to say onChange handler, and then it's going to need options. And so options is the keyword that React Select is using for its current value. And so what we need to do is keep in mind that we want to be able to get access to this value later. So what I'm going to do is pass a function here inline, and I'm going to say this set state, this dot set state, and we'll say tags is equal to, and right here we're going to say tags. So technically what we expect is that the React select component, or the creatable select component, every time the onChange function is called, it's going to pass us the current tags that are stored in the input, or that are typed into the input. So what we want to do is put those onto state, one, so that we can reference them here in our code. So just to skip ahead, we're going to say this.state.tag. So we're going to tell the React select component, hey, here are the tags that we've typed into you, keep track of those, but also so that later, when we need to actually send this data to the server, we'll be able to easily get to it via this.state.tags without having to jump through a bunch of hoops. It's going to make our life super easy. And so right here, to finish this out, technically I could write tags like that, but you'll notice my linter is yelling at me. It's saying, I expected this to be shorthand. And that's because what we're doing here is we're assigning this property on this object that we passed to set state. We're assigning that property to a variable with the exact same name. And so as of, I think it's ES6, it might be ES7, but as of ES6 we get property shorthand on objects. So if we're setting the property on an object to a variable with the exact same name as that property, we can just set the property name directly, and JavaScript is going to interpret this as, oh, okay, I'm just assigning tags to a variable with the same name that's in scope of wherever this is being called. So in this case, we can get rid of the colon and the actual variable name being passed, and JavaScript will interpret this just the same, which is pretty awesome. And so now that we have that, we technically have everything we need for the select input, but we still have to fulfill this dependency of our styled component for document tags. And this is basically just going to be a box that we draw around the document tag so it doesn't look totally hideous in terms of our interface. And so if we go back up to the top of our file here, what we can see is that we're importing all of our styled components from another file that's in the same directory. And I know it's in the same directory because of that /. It's in the same directory as our document editor component. So notice it's called index.js inside of the document editor folder. So that index.js is saying, hey, this is the actual component itself. And then styles.js here contains all of the style components that we've defined in relation to that document editor or for use inside of the document editor. So what I'm going to do is say down here at the bottom, export const, And so this is going to give us a named export or a named variable coming from this file. And we're going to call this document tags. And I'm going to set this equal to style.div and then use this funky backtick notation. So with style components, what it's doing is it's saying I'm going to create a React component that contains a div, and then whatever you pass to me in these backticks, I'm going to apply as styles. So what this is effectively doing, even though it may not look like it, it's just saying this. So JavaScript is interpreting this as we're calling a function named div, and we're passing that function a string. And so this is another one of those JavaScript mysteries. Not really a mystery, it's just the way that it's implemented, which is because we're passing those backticks directly after this keyword here, this method or property of styled, we're saying div and then backticks. What that's being interpreted as by JavaScript is, oh, div is just a function that returns a string. And so we can just pass the string immediately after and save ourselves a little bit of work in terms of typing out some parentheses, which is kind of neat. So inside of this, we're going to add some styles, and I'm just going to take a guess here, but I think we're going to need about, I want to say 15 pixels of padding, and then we're going to give it a border of 1 pixel solid. We're going to use a CSS variable here called gray lighter, and this is predefined in pup, so this is not something that you have to add. If you type this into a file in pup, it should be defined, and it's just a light gray color. And if you haven't heard of CSS variables, I highly recommend going and checking them out. It's pretty quick to learn them. There's not a lot that's involved, but they're super valuable. And if you've worked with things like Sass or SCSS before, and you've used the $ variable, this is the exact same concept, but what's neat about it is it's the core CSS implementation that supports it now. So there's no compilation of any files being done. This is just built into CSS now, which is awesome. So we're going to add our border, and I already know kind of in my head where this is going to fit in the UI, that we don't want it to have a border top because it's going to sit between two boxes that already have borders. And so if we have border top on there, it's going to create a double border and look a little funky. So we're going to get rid of that. So that should just about do it. We'll have to look in the browser, but that should just about do it. And so what I'm going to do is import that now right here, and we'll put it in line with how it actually appears in the UI. So we'll put this in between the body and the footer. And we're going to say document tags, and then go ahead and save that. So if we jump back to our browser now, after a few seconds we should get a refresh, and there we go. We've got our tags input, and we can see it rendering. And let's try and use it. I don't know if we did everything we need to do. Are we lucky? Ha! We are. And we know that that's working because if we come back over here to our document editor, remember that when we defined our creatable select component, what we did was we told it its current value. So we said, hey, your options are this.state.tag. So it already is proven to us that it's working, because if it wasn't working or we had made a mistake in terms of our state value, what would end up happening here is we would call this and there would be some sort of error. It'd say, I can't read this property, or I can't do this. So that's great. But the reason that I'm a little hesitant here to believe that it's working is because we forgot a little step, which will come in handy in a little bit, and that is in our this.state objects, or default state object that we set when our component is created or constructed for the first time, we should add tags as an empty array. And the whole reason for that is we're going to need to be able to retrieve these tags in a little bit and populate this input by default with some value. So what I'm going to do here is just say, you know what, just to be safe, in case the user doesn't add any tags or something like that, we'll always return an empty array, so that way our UI doesn't break. And so now we're moving here. So let's say add a tag. I don't believe it, but okay, great. So we've got our tags, and now what we need to do is actually send these back to the server to be stored in our database. And so what we're going to do is up here in the URL bar, I'm going to copy the ID of our document, and I'm going to open a tool I like to use for exploring my database called MongoHub. And I've got a connection to my Meteor server already set up. So if you've never played with anything like this before, I would recommend checking out MongoHub. And if you Google real quick for something like adding Meteor database to Mongo Hub or connecting to Meteor database locally, there's instructions in there. There's not a lot to it. All you're doing is adding the URL of the Mongo database for your Meteor application and the port number, and then that's it. Everything else just wires up. But if you Google that, you'll be able to find it, no sweat. And if you have any problems with that and you want to do that, just leave a comment for me down below and I'd be happy to step you through it. So what we're going to do is go into Documents here. I'm going to paste that ID. We can see that it finds it for us, and if we look right now, there's no concept of tags on this document. And so what we need to do is get our tags from that input into the database here. And so remember, we've done all the work that we need to do back on the server in terms of our GraphQL schema, but our client isn't telling the GraphQL schema technically right now, hey, I'm going to send this to you. So what we need to do is if we look down here, we can see a mutate method. And that mutate method is being passed to this handle update document method that's defined on our document editor component. And so if we go back down here to the render method, what we can see is that we're using a component called Mutation. And this component is coming from the React Apollo package. So not React, but the Apollo part of React Apollo. So Apollo is a client-side library that's coincidentally actually built by the same folks that build Meteor. So the same exact team that builds Meteor builds Apollo, but Apollo is designed as being completely independent of Meteor. So same people are building it, but Apollo can be used inside of Meteor like we see here, or it can be used outside of Meteor. So that's a totally separate project, just happens to be managed by the same people. And so what we're doing here is we're importing the mutation component from this React Apollo package. So this is Apollo's React implementation of all of its tooling. And what Apollo does is it gives us a set of tools for the client side of our application for communicating with a GraphQL server. And it doesn't matter if it's a GraphQL server in our application. So like we see here in PUP, we use that PupQL package that we have to start up our server. It could be a server like that, or it could be a third-party hosted GraphQL server that you want to connect to. It doesn't really matter. Apollo is just giving us the capability to talk to that server. And so this mutation component is just a helper component for performing a mutation on our GraphQL server. And so if we look here, what we're doing is we're loading potentially one of two mutations. So we're not going to go into too much detail on what this is up to, but just know that when the value of this state mutation changes, what we're doing is toggling between either updating a document or removing the document. And so this mutation component is loading the contents of that mutation for us, calling it, and then what it does is it uses a render prop. So if you've never seen this before, we're inside of the component at this point. So we're at the point where you technically render your children. But what we do is for the first or most immediate child, we pass a React expression with a function inside of it. And if you look, it's just rendering something. So this is known as a render prop. And what this is doing is it's saying when the mutation component renders itself, so literally this part up here, when that renders, it's going to do some work behind the scenes. And then once it's done or once it's ready, it's going to call this function to actually render the code, or render the JSX in this case, that it contains. And so if we look here, it's calling a function that renders that code, but it also passes us an argument called mutate. So that mutate is being passed to any of the times or any of the any of the times that our document is being updated. And so if we look down here, and I gotta honestly kind of look close here, getting old. There we go. So we can see in a few different places we're calling functions that are controlling the current status of our document, the current value stored on our document. So here we're talking about whether or not our document is public or private. And you can see when we call that function, we pass that mutate that's coming in, again, from this render prop. And then I know somewhere in here, I think it's around the title and the body inputs. There you go. So we call handle update document passing mutate. And we call it again passing mutate down here when the body changes. And so what we need to do right now is make a quick change. And I'm going to copy this whole function here that's calling to handle update document for us. And that exists just so that we don't accidentally call handle update document as soon as this component renders. That outer function means that when onChange gets called, this function gets called, and then that function acts as kind of a proxy to call this .handle update document for us, and it allows us to pass in a value. So in this case, it's allowing us to pass mutate to our calls to handle this .handle update document. And so what we're going to do is copy that. We're going to come back down here to our creatable select, and what I'm going to do is add a callback function to our call to this .set state. So to make sure this is super clear and easy to read, I'm going to copy this, add some braces like that. We're going to add some spacing here. So what we're saying with this is this .set state, the value of tags to whatever we were passed from our React select components tags value. So go ahead and set that. But then as soon as that's done, what we want you to do is call to this .handle update document. So literally as soon as we've added some tags, go ahead and update the document with those tags. And so what we need to do now is inside of handle update document, make sure that we know about those tags. And so if we come back up to handle update document here, what we need to do is just beneath body, we're going to add tags. And remember, and this is where the state value comes in, we have our tags on state. So we're going to say this.state.tags. Now, that's close enough, but it's not great. And there's a problem here. So this.state.tags currently, even though we haven't seen it, I just know this because I've worked with this component before. What it's doing is it's storing each of our tags not as a string, but as an object with a label and a value property on that object. So that's just the value or the shape of the value that React Select expects. And so remember, back in our GraphQL schema on the server, we told it that we expect an array of strings, not an array of objects. And so we have two options here. We could go back to our server and tweak all of our code to say expect an array of objects, or we could say, like, nah, let's be pure and let's stick to what we did and do this as an array of strings. And that's what we're going to do. So what I'm going to do right here is very simple. I'm going to call to .map on tags. And so .map is just a JavaScript function that's added to the array prototype in JavaScript. So that means that all arrays in JavaScript can have this map function called on them. So we're saying this.state.tags, we expect that to be an array of, in this case, objects. So we're going to map over that array of objects. And what we're going to say is for each one of those, we want to destructure. So here we're expecting each one of these to be a tag object. And so I'm going to use JavaScript destructuring to say, hey, open that object up. And specifically, all I care about is the value property on each of those objects. So again, we expect it to have label and value as possible things that we can get from it. But here we're just saying, just give us the value property and give it to us as a variable called value inside of this function that we're creating, or where we're adding it as an argument. And so what I'm saying is for each tag that you loop over, that you map over, go ahead and just give me the value. And so if I return that directly from this function, and again, if we don't have braces here, this is just an implicit return. So what we're saying is for each tag, go ahead and return just the value. So in this case, literally whatever the value of that value property is, just go ahead and return that. And because we're inside of a map function, what a map function does is it returns a brand new array with whatever is returned here. So for each one of these, say we have 10 different tags, we're going to get back an array of 10 strings that are the values. So if we run through, so if we have this example here, let's just type in, I don't know, pizza. I don't know why pizza is the thing on the brain, but pizza is the thing on the brain. Maybe that'll be dinner. So we're going to say for each one of these, we want to just get back pizza. So after map, what we'd expect back is something like pizza. And if we had more than one of these, it's pizza 2 or pizza 3 or whatever we typed in for the tag name. That's what we'd expect to get back after we do the map. So here now we should get our array of strings. And something that's really good to do when you're dealing with code that you're uncertain about is, and let me get rid of this comment so it doesn't mess up what I'm about to do here. So what you can do is copy whatever value you're trying to send to the server in its entirety and just log it out. And I do this constantly. So I'll take a console log, and typically I'll send data, because it's more than one thing, I'll send it as an object from the client to the server. What I'll do is I'll log that object out right at the point where I'm trying to send it to the server. So in this case, because we're calling mutate and it's calling our mutation for us, I expect it to, like right at that point, that's where it's going to be used. So that should be the last moment where it could screw up before it goes to the server. That's where I would expect to see it right before something goes wrong. And if not, I can backtrack from there. So it's a really great way to kind of organize what's going on and where things might be breaking. So what we're going to do is jump back to the browser here, and I'm going to inspect, go into the console, and we're going to say add a tag, and there we go. So we can see that the object I just logged is coming out with, what do we got? We got an ID, we got a title, a body, and tags as an array of strings. And again, that's working because we did this map here to make sure that we only get back the value for each of our tags. So that's great. This is more or less working. And one thing you may be wondering is, well, wait a minute. How do we know what we're mutating? How do we know what we're changing? And this I purposely left out just to make sure we could get up to this point quickly without any fuss. But what we need to look at next is actually defining a mutation on the client. So in order to understand this, what we need to do is look back down here at the mutation component I showed you earlier. So remember that mutations are the thing that's allowing us to change or mutate data in our database. So in GraphQL, or when you're working with GraphQL, you have two sides of this. So you have the server, which we already saw, so we have to define the mutation field and then the mutation resolver. But on the client, we also need to define the shape of the mutation as well as what we expect back in response to that mutation. If we look here, what's going on is, again, whenever this.state.mutation changes inside of the document editor component, what we're doing is toggling between either update document or remove document. And so if we look, this update document variable is coming from an import at the top of our file, so is remove document. And if we look, they're both coming from the same place. So this is coming from mutation/documents.gql. And if we look inside of our application, this is coming from UI mutations documents.gql. So this isn't a GraphQL specific thing. This is just how PUP organizes all of its GraphQL queries, mutations, and subscriptions on the client side. So as you can see here, I've opened up that documents.gql file, and it's got a bunch of GraphQL mutation queries. So again, queries are for reading data back and mutations are for changing it. Both of those on the client side are going to use a similar syntax, so don't let that confuse you. So the separation between the two, or the important separation here, is that you'll notice all of our mutations start with the keyword mutation. And if we look real quick, so I'm going to open up queries for documents, and we can say all of those start with the keyword query. So that's our separation between the two, so that we know what we're actually dealing with and we don't let the syntax confuse us. So back here in documents.gql, we can see that we've got add document, and let me make sure that we pull up our schema again. So this is in startup server API.js. So if we look in here again, we have update document and add document are the mutations that we need to worry about. And if we look here, title body tags on add document matches title body, and that's what's missing. So we need to add tags, and we need to make sure we do it as $tags out here, and I'll explain that in just a second. So we're going to say $tags, and again we expect it to be an array of strings, and then we need to pass that again down here as tags without the $, and assign it $tags. So this is a little quirky, so this is just the way that the GraphQL syntax works. But when we're dealing with a mutation that takes in arguments, what we need to do is wrap it with this syntax where it's the keyword mutation followed by the name of the mutation, and then we tell it all of the variables that we expect to be passed as $, the name of the variable, and then inside of that, and I guess you could call this an object. Again, we're dealing at this point with GraphQL's domain-specific language, or DSL, and so technically this isn't an object, but it looks like one. So for the sake of right now, we'll call it an object. So inside of that outer object, we pass our actual mutation query, and to that we pass our variables again. So this is kind of like variables being passed as variables to this. Kind of funky, kind of weird that you got to duplicate it, but that's just the way it is. Hopefully it improves in the future, but just know that what we're doing here is saying these are the variables that are being passed, and then we're going to assign them to the actual mutation right here. And if we look closely, again, this is for the add document mutation, what we're saying is pass these values to the server, but send us these values back. So this is one of the powerful things about mutations in GraphQL is we can say, hey, go ahead and go up to the server, do some work, like add some documents or update a document, whatever mutation work that we're doing, but then return us a value back. So we can use this on the client to do all kinds of stuff. And in PUP, what we do is we update the client-side cache with that data. So we say, hey, this document was just added over on the server. And that's an important concept, and that's not something we're going to cover really that much in this video here. But the cache is something that Apollo package that we get maintains for us. So the cache is just a copy of what's been queried already from the server, and it just keeps a copy of it around so that way we're not constantly going back to the server to go get data that may not have changed. We don't really need to constantly go refetch that. That's a waste of bandwidth and just performance on our application. So all that's doing is it's saying store a copy of it. So again, that's what we're doing here. We're saying return us these fields on this document so that we can update that document in our cache. And again, that's all we're going to explain for that for now. Maybe I'll do another video later on specifically how to maintain that cache and work with it. But just know that that's where that's going. So that was add document. And update document, the same exact rules and same exact concepts are applying. We're just doing it on a different mutation. So here, update document, we got to be very careful here. So update document here and update document here are technically unrelated. But you'll notice that in PUP, we're naming the outer mutation call the same thing as the inner mutation call. So this inner one is the same as the value that we define in our schema back here. So update document here and the resolver function update document are identical to what's being called right here. Whereas this outer one, this is just a name. So if this was just a file with some functions in it, this is equivalent to saying something like export const update document, where update document is a named variable that we're exporting from the file. This is a similar concept at play here. And we know that because if we go back, going back too far. There we go. So if we go back to our component, we can see that when we import these as named variables or named exports from that document's GQL file. And so update document here is matching the outer update document here. So if I call this update documents with a Z, this would be update documents with a Z here, and then we'd have to update all the code below. Obviously, we're not going to do that, but just so you understand that mapping. And so that's where we define on the client, hey, this is a mutation that we're going to call, and that tells our client side how to communicate back to our GraphQL schema on the server that this is what we're trying to do. And so now, if we look, again, that mutation component loads whatever mutation is passed based on state here. And this is a rare case, so this is just the way we built this UI that we need to do this state toggling. Typically, most of your UIs, you're going to do something like this. So it's not going to be terribly complex. This is just how we built the document editor inside of PUP. And we also did it on purpose, so this is so you can show how to toggle between multiple mutations on the client using this mutation component. So that's all that's happening there. Don't let it stress you out too much. So again, because we're passing that as the mutation here, that assigns whatever that mutation is to this mutate function. So when we call mutate, and again, that's being passed to all of our handle update document calls here in the documents. When we change tags, body, or title, we call handle update document passing that mutate function. So now that mutate function effectively is pointing at the update document mutation. And we know that because that's happening whenever we make changes to the document. And we can see inside of the handle update document method, when we call this.setState mutation to update document, that's us saying right down here on the mutation component, hey, switch to that mutation. And so if we come back up here, we set it, and then we call it. So in this case, I want this one. So that was handle set visibility that I landed on. All of these look fairly similar, so you got to be careful. But here, handle update document, set that as the mutation that we're trying to load, and then we call the mutate function, and now that mutate function should be pointing at handle update document, and we pass here our variables. So I didn't point this out too well earlier, but if you look, variables here, this object is matching all of the variables that we're passing here, and then passing here. And did I do, oh, I only added tags to add document. We forgot to add it here. So all of the, let's make sure I do this right here. All of the arguments that I'm passing here as well as down here. And so we're going to do tags, $tags. There we go. So all of the arguments that we're passing here, and then those arguments, again, match what we expect up on the server. So we have add document and update document mutations, both expecting tags as possible arguments, and we expect those to receive an array of strings, both on add and update documents. So that should take care of us on the client, so, or at least in part. So what we haven't done yet is load this data back from the document into the editor. So if we move away from the document editor and come back later, we want to be able to see those tags. We haven't done that yet, but let's just take care of updating the actual document in our database first. So what I'm going to do is just give the browser a refresh, just because it makes you feel warm and fuzzy. And we're going to say add a tag and another tag. And this is good, so we're not getting any errors, and we are passing these to the server. So what I want to do is open up my Database Explorer again, and I'm going to rerun this query. And there we go. So we've got our tags storing in the actual database on our application. Now this is getting us, I would say, about 90% of the way. We're almost done here. But if I come back to the page here and I refresh, see what happens. Fudgicles. We're missing our tags that we just added to our document. But if we go back to our database, just to prove it, I'm going to refresh this. And we're going to look and we can see, oh yeah, you know what? There are tags in our database. So what we need to do is make sure that those are a part of the query that we're running on the client when we edit a document. And so just like we saw with mutations on the client, if we come back to our UI directory, we're going to go down, instead of mutations, we're going to look in queries and documents.gql under queries. And we can see that when we're querying documents, there's a few different cases that we're going to read back documents from our GraphQL schema, or ultimately from our database. And so if we look here, we've got documents as a query here, and this is when we're loading back the list of documents back here on the index. But what we care about here is the one right beneath it, which is edit document. And you can see here we call to the document query, and we're saying, okay, we want you to return the document at this ID. And just to make sure that's totally clear, if we look, the document query here, the document field that we're querying against, if we go back to our API, that matches this field here, and it matches the document resolver function back up here. So if we go to API documents, and not documents.js, that's not what we want. We want API documents queries. And if we look here, we have a document function. So again, that document function matches this document field, matches the, let's close that, that's our mutations, matches the document field that we're querying here. So all three of those, the names are identical and map one for one to each other. So if any of those change, we'd have to change the others. So what we're doing is we're saying, okay, when we call that field, we expect it to return something that looks like our document type that we set up earlier. And again, our document type is this goober that we talked about as our first thing in this tutorial. So what we expect is data that looks like this. And again, we added our tags field to this, and we expect that tags field to contain an array of strings. So if we look back here, what we're doing, you'll notice the spread syntax that we saw a lot earlier. So back here, if we look down in our resolver functions, we've got the ... This is another confusing one. So this is still GraphQL's domain-specific language, or DSL. So the ... here is designating that document attributes is what's known as a fragment in GraphQL. And a fragment is essentially a variable containing fields that you're going to ask for on multiple queries. And if you think about what a variable is in JavaScript just as is, it's something that we can reuse. So if I store the name Clever Beagle in a string, or I put it in a string and then I assign that string to a variable called company name, I can reuse company name throughout my code in multiple places. Fragments are the exact same idea for your client-side queries. So what those are doing is they're saying, you know what, we're going to ask for these same fields again and again and again. And so notice here we're typing out exactly what we want back from the query. So what fragments are doing are they're saving us the trouble of having to type out all of those same fields again if we don't actually want to do that. So we can compose them or store them in a fragment. And you can see up here GraphQL or GQL's import syntax. In case of this file, you use a hash mark and you say hash import, and then you give a path to wherever that fragment or that other query file is. And again, don't worry too much about that. Just know that here in UI fragments, documents, GQL, that's what's being imported up here. And by virtue of importing that, we get access to this document attributes fragment. And if we open up documents GQL under fragments, we can see document attributes is being defined. So the syntax for this is you say fragment, and then the name of your fragment, and then you say which type of data it's being defined on. So we anticipate that this is going to be used as a fragment on a document type of data. And so let's go ahead and go back to our queries now. And actually, no, I take that back. We need to modify that fragment. And if you look close, the reason why is this fragment has no concept of tags, but we want to make sure those are returned. So I'm going to add tags right there. And this is the beauty of GraphQL. That's all we need to do is just say tags there. And now when we run our document query, and in this case, edit document. So again, we're naming it edit document because these are the fields that we need when we're editing a document in our application. So we want to return those back to that query. And if we come back over here into index.js on document editor, I want to say, is it at the bottom of this one? No, it's not. You know what? It's in UI, and it's under pages, edit document, I believe. Is that true? It is. So we're using a slightly different syntax here than what we saw earlier. So earlier when we wanted to load our mutation, we used a mutation component. The same exact things for performing queries in GraphQL, or specifically in the React Apollo package. So there does exist a capital Q query component that works in the exact same way as the mutation component. So it uses a render prop that says, once we've downloaded the data, or once we've received the data from our GraphQL query, render this JSX, passing the data that you got back excuse me, from the GraphQL server in response to that query. And so here, we could use the query component, but instead, we found that for most cases inside of PUP, it makes sense to just use this GraphQL function that's also exported from React Apollo. And so what this does is it gives us a function that takes a GraphQL query and an options object, and then it returns another function that you can call and pass the component that you want to wrap that data with. So if we look here, the edit document component up here is expecting an object or a props object with data and history defined on it. And so data here is coming from this call to GraphQL. So what's happening here is we're going to run the edit document query. And again, you can see up here we're importing that edit document query from query/documents GQL. So this is back over here, what we were just looking at. We're importing edit document here as edit document query, and then we're passing that to this GraphQL function so that we can actually run it or execute it on the client. And what that's going to do is it's going to load our data for us. And we can see here we pass it an options function, which returns an object, and in it we have variables. So here we're saying underscore ID is equal to match params ID. So match is coming from our router, and it's saying, hey, we expect an underscore ID param in that route's params object. And so we're saying to GraphQL, hey, pass underscore ID as an argument or as a variable. And if we look back here, we can see ID is coming through here, and then back up in our API, we can see, hey, if we were querying for document, we get underscore ID and we expect it to be a string. So all of those are exactly the same. And so all this is doing is saying, call to the GraphQL server, executing this query with this underscore ID, and then once you get a response, pass it as the data prop on this edit document component. So up here, data, if we look, is going to have a .document field, and that document field is going to contain the document that we retrieved from our database. And so now, if we back up here and hit save, what I'm going to do is go back into Document Editor, and I'm going to go up to our constructor. And what I want to see, because I'm not 100% sure, I want to log out the props that are being passed to Document Editor. And so what we want to see is when this document loads up, does it actually receive the tags that we expect back? So here we can see our document was logged out, and we can see, yes, we do. We've got our tags just like we'd expect. And that's because we added that tags field to our GraphQL type earlier, and that type is expected as what we're going to get back from our document query in our GraphQL schema. So remember that earlier we had to convert our array of tags from an array of objects to an array of strings to store it in our database. Well, now because we want to put it back into our React Select component, we need to convert it back to that array of objects. So what I'm going to do up here in the constructor is, remember earlier we talked about setting tags to a default value. We're going to keep that empty array, but we're going to put it after an OR statement. So what we're going to do is we're going to say props and props.doc and props.doc.tags. And so if we go back to our browser real quick, we can see this object here is representing the props passed to this component, and doc is literally the document that we're trying to load into the editor. And we expect that doc object to have a tags property or a tags array assigned to it. So what we're going to do is say if props exist and props.doc exists and props.doc.tags exists, you know what, I'm going to move this up into a variable just so it's not totally confusing. So we're going to say document tags equals that. So I'm going to say, in this case, let's rewrite this a little bit. So we're going to say document tags question mark. So again, we're using a ternary operator here, which is like a condensed if-else statement. So we're going to say if document tags is defined, what we want you to do is say document tags.map. And remember, map is allowing us to map over an array, an existing array, and return a new array with some value based on what we returned from our map function. So in this case, we expect an array of tag strings, and remember that React Select is expecting an array of objects with a label property and a value property, both of those being equal to the actual tag that we typed into the UI. And so here we're probably getting yelled at for spacing, so let me just space this out real quick, make it a little easier for you folks to read as well. There we go. Let me just tap that down there, and there we go. Okay, so now what we expect is we're going to load our documents tags from props back into the default state value. So because this .state.tags is being loaded no matter what into our creatable select here as the options, what we'd expect is that those tags should show up in the UI once this reloads. So if we refresh, we're not getting anything. We are, but we're not getting them in the input. We're getting them as tags down here. So what we need to do is go back over to creatable in the React Select docs, and what we want to check is what the value needs to be. And I'm going to guess that React Select, so we're going to say go to the API docs, and I'm going to look for something like value. Oof, that's a mistake. Let's see, creatable props. What do you have? Say anything about values? Not really. Let's see here. Can I get something like value equals? No. How about a default value? No. Okay. So what I'm going to do real quick here is I'm going to pause and find this for us, and then we'll keep going. Alrighty, so I was able to find it. It actually is just called value. So we add, in addition to options here, we're adding value equals this.state.tags. If we jump back to our browser here, I already did a refresh just to test this out, but it does look like it's working. So there we go. We added tags to our component. So let's just have some fun now. So we're going to say Beagle's rule, bark, arf, woof. And we can see this is updating. So if we refresh, we should have those back in the input. And there we go. We've got a working tags feature on our documents. So the very last thing that we can do here is if we click on this drop down, we can see we've got a view document option. And it'd be nice if we could see our tags down here. And we don't need to be terribly fancy about this, but I do want to get these into the document. So what we're going to do is go back over to our application, and we're going to find the view document page. And what we need to figure out is where we're going to put this. We can see here we've got the title and the body of our document, and I'm just going to be a little bit lazy, and we're just going to smack a paragraph on the bottom of this, just so we can get that nice comforting validation that we did something correctly all the way through. So we're going to say data.document and data.document.tags. Now, remember that we're storing tags as an array of strings, and one of the cool things in JavaScript is that if we output an array of strings inside of something like a paragraph tag in our UI, typically what JavaScript is going to do is it's just going to output those as a comma-separated list of values, or a comma-separated string with all of the values in that array, or all of the strings in that array. So if we save that and jump back to our browser, there we go. So it doesn't look pretty, but we are getting our tags on our document. So to save face, because I know this was kind of a long one, I'm going to stop us there, but we can see that we've got tags adding to our actual document here. And then if we go back to our editor, and we'll say, thanks for watching, folks, folks. And that's updating in real time. So now if we go to view the document again, thanks for watching, folks. So that's going to do it for this Feature Friday. I really appreciate you hanging in there with me and watching the whole thing. If you have any questions, do please post a comment down below. I'm happy to answer it for you. Usually it takes me a day or two to get back to you, but I will get back to you. So again, thanks for watching. If you haven't already, make sure to hit subscribe on this channel, because we are going to be posting these every Friday. This one's a little different. It's coming out on a Monday just because I had a few other things I had to do last week, so I didn't quite have time to get this one right, but it's coming out today on Monday. But subscribe, and they should be coming out every single Friday for you. And also make sure to hit the notification bell. That way you'll get them as soon as they're published. So thanks for watching, folks, and we'll see you next week for another Feature Friday. If you enjoyed this tutorial, I'd really appreciate it if you head over to cleverbeagle.com/subscribe and sign up to get our latest tutorials and advice in your inbox as soon as they're published.